equals x, negative x. So y is 1/2 x. Here we go. You go up 1 over 2. And then, okay, for these, you have to be extremely precise. That means it has to be graphing paper, right? X and Y axes have to be done like very meticulously, and you have to draw these with a ruler. Because if you're a little bit off, then everything is a little bit off, right? So, okay. And then the other one is y equals negative x plus 6. So negative x plus 6, that's right there. Down 1 over 1. You graph. Okay, I was a little off over there. And here we go, right? When you graph, do you see how this point is where they intersect? That's the solution. That point is 4, 2. That's the solution to this, right? So for the solution, you're going to say 4, 2. All right? Okay, now go ahead and take out your calculators. And let's put that over there. Let's put that on the calculator. Okay, so what you're going to do is you're going to put the first equation into F1 and the second equation into F2. Okay, so when you open up your calculator, okay, I don't want this. Okay, so here we go into the calculator. To delete them, here's what you can do. Okay, so press this calculator button. To delete, you can go up to Scratchpad and clear. You can go up to Scratchpad, press B, and it clears the Sketchpad for you. If you press this button, the calculator button, it goes back and forth between the graph and the home screen. So here we're going to put 1/2 x, right? And you can do that in a whole bunch of ways. You can do 1 over 2 times x. You can do 0.5x, whatever. Press enter. To go back to put something else, you're going to put tab. And we're going to put a negative x plus 6. Okay, make sure you don't put the minus and you put the negative sign because that makes a difference. Okay, here we go. Now look, everybody look up here for a minute. You see how like these equations are on top of each other and it's kind of a mess over there? What you can do is this. If you move the cursor onto one of them, you see like the little hand over there? Press the center button down, press and hold, and it has to be more than a second. I know it's more time than you're willing to invest sometimes, but just press and hold for more than a second, and you see it grabbing the equation, and you can drag it and put it somewhere else. Same with the other one, you can just drag it and put it somewhere else. Okay, now comes the good stuff. Here's what you're gonna do. Yep. Press menu. Analyze graph, and we want the intersection of these two, so press intersection, and then you get this dotted line. Scroll and put it to the left of the point of intersection, and click. Scroll and bring it to the right, click, and look, you see the intersection is 4, 2. Okay, and by the way, you also have it right here. Okay, on the bottom of the page that we're working on. So menu, analyze graph, intersection. You get this vertical line and you drag it with the trackpad to the left and hit the center button to set it. Then drag it to the right and you'll see a range. Hit the center button and set it, and then it'll find it for you. Okay? All right, questions? It is kind of cool.
It's not letting me grab it. It's just moving it.
So, okay, we'll come back to it. Okay? Escape out of it, and then we'll come back to it later. But for now, we're going to move on. So, just close the calculators again and just put them off to the side. Yeah. Okay, we'll try again in a little bit. Okay, but you should also be able to do it by hand. Okay. So, let's move on. So if the solution to these is the point where it intersects, right, you can already figure out that there could be different varieties of how those graphs look, okay? You know, you can visualize like thousands of sets of lines where they cross at one point, right? But also, if we move back here, right, it could also be possible to have two lines that are parallel to each other. And if the solution is where they intersect, well, two lines never intersect with each other. It means if two parallel lines never intersect, so if they're parallel, there is no solution. It could also be that the two functions are actually the same exact graph, like the same exact function, right? In which case, if you graph them, they will literally lie on top of one another, like the case in the middle here, okay? At how many points, so that's two lines on top of each other. At how many points are those two lines intersecting? Not every, yeah, so every point on the line, right? But the solution to this is not all real numbers, which a lot of students want to say, right? All real numbers would be like, this is a solution, and so on. We just say it has infinitely many solutions. And before you start asking, can we abbreviate that? Just, let's leave that for later, okay? Infinitely many solutions if it's the same line. So there are three possibilities. One solution, infinitely many, no solution. Back in the day, right, we used to stress this as well, that, each of them are called consistent and independent, dependent and inconsistent. I'm not going to stress that too much or at all, but you should know one solution, infinitely many, or no. Okay, other ways to solve equations are substitution or elimination, which you guys have seen before, right? Okay, so it's very important. Sometimes you can just tell by looking at, the equations even, that they're going to be, the same equation, right? And they like lie on top of each other. So for example, if you have, y is equal to 3x plus 2, and then if you have, another one, y is equal to, 6x plus 4. Do you see how one is just twice the other, right? So if you divide everything by 2 here, like it's the same equation. So you'll see. But let's take a couple of examples. First, we're going to do the substitution method. To do this, solve one equation for one of the variables. That means you're either going to do x equals something or y equals something. Substitute into the other equation to replace the variable. And then once you solve that one, you substitute again to solve for the second variable. So let's just do one. How do you know if a problem is a good problem to do substitution? Usually, you will have one of the variables with a coefficient of 1 or -1, okay? All right. So this one, for example, y is alone. So I can solve this for y, and it's -2x plus 7. Now, I take that and plug it into the other equation. So it's going to be 5x minus 3 times y equals 23. Okay? So 5x plus 6x minus 21 equals 23. Guys, be careful when you're distributing those negatives. Some of you are not distributing to the second term. 11x is equal to 44. X is 4. What do I do now? Plug it back in. Where do I plug it back in? So guess what? I can plug it into any one of these. right? The easiest is for this one where I've solved for y already, okay? So y equals negative 2 times 4 plus 7, and I get that y equals negative 1. So, am I done? Is this how I leave it? No. Answer is 4 comma negative 1. All right? Okay. What about the next one? What are we going to do first?
You're gonna solve the first part and then substitute it.
Solve for x. So x is 7y plus 11. Substitute it into the other one. So 5 times 7y plus 11 equals, plus 4y. Don't you love these? I can do these all day. I do these all day. Plus 4y equals negative 23. 39y, oh my God, now we have a number greater than like 17 and people start freaking out. Am I doing it right? Yeah, because 39 is also a number, right? It's fine. Is equal to negative 78. Y is equal to negative 2. Now what? Plug it back. X is negative 3. So I got negative 3 comma negative 2. Now, are we always going to get cute little integers like this? No, not in honors anyway. Okay, so watch out for fractions. That it's okay, right? Don't think that you did it incorrectly if you got a fraction. All right, next. The last method is by elimination. Okay, solving by elimination. In this case, you have to multiply one or both equations by a number so that you get opposite terms. What do we mean by opposite terms? You want, for example, either the two x's or the two y's to have the same coefficient but opposite sign, right? So positive 3x, negative 3x, okay? Positive 7y, okay? So for example, positive 7y, negative 7y or whatever, okay? Then you add the equations and one of the variables will get eliminated, solve it, and then substitute again. So let's do it. This is one of my favorite things to do. Huh? Yeah, because you're on your calculator. Put that down. Thank you. Okay. So take a look at this one. It's already, right, in the form that's like screaming elimination, right? So that's the thing. When you see a problem, no one's going to tell you solve it this way or that way. You have to be able to recognize. So look at this one. You have negative 3y, positive 3y. Like that is like prime elimination problem, right? So what I have to do now, since this is negative and positive of the same number, just add the two equations. 4x plus 2x is 6x. Negative 3y plus positive 3y, go away, 0, equals, add this, so you get negative 6. So what's x? Negative 1. Okay, now you have to solve for the other one, right? Plug it into whichever one you want. It doesn't matter at all, okay? What do you guys want to do, first one or second one? Second it is. So 2 times negative 1 plus 3y equals 16. Negative 2 plus 3y equals 16. 3y is 18. And y is 6. So this is negative 1 comma 6. Common mistakes, which I know won't happen here. Can you sit straight? Okay, common mistakes. Sometimes, like if students solve for y first, then x, they'll put it in that reverse order. You guys are in honors. You gotta be above all that, yeah? Okay. What about this one? What are we gonna do here? Multiply one of them by negative 1. So why don't we multiply this one by negative 1? Okay. So I get the first one stays unchanged.
Wait, why don't you just add it?
Well, because they have to have opposite signs for you to add.
It's the same thing as the 3y.
No, because one is negative 3y, one is positive 3. So here, negative 4x plus 5y equals 12. Add these two, and I get 2x plus 0 equals 4. X is 2. Okay, go ahead and solve for y. Let me know what you get. X is positive 2.
Why can't you just subtract all?
You can subtract it, but make sure you change all of them to negative. It's always easier to just change this. Okay, so if you subtract it, it'll be 6x minus 4x, 2x. Negative 5 minus positive 5. And then negative 8 plus 12. So you can do that, right? It's the same. I believe so.
Okay. Are you allowed to multiply, like, are you allowed to plug it back into the equation before you multiply it by the
Yes, yes. Any one of the equations will do. Okay, so x is 2. What did we get for y? 4. Okay, so it's 2 comma 4. Okay, the next one, I've got 2x, 6x, 3y, 9y. So either way, I have to multiply by a number as well and make it the same. So one thing we can do is what? Multiply, what can we multiply the top equation by? Negative 3. Negative 3 works best because then I also have opposite sign. So I get negative 6x minus 9y equals negative 15. 6x plus 9y equals 15. Now look, this is important, okay? When you add these, what do you get on the left-hand side? 0 equals, okay, and when is 0 equal to 0? All the time, right? That means this is infinitely many solutions. Okay, now here's a question for you. If it's infinitely many solutions, what do we know about the graphs of these equations? They're the same exact line, okay? Yep.
Is there a reason you can't just write solutions?
I mean, as opposed to infinitely many?
Yeah.
I mean, just write the infinitely many. Wait until you get to calculus, and then you'll see how much writing there is over there, okay? All right, so, Okay, let's do the next one. Okay, common mistake. Students will multiply this, we'll forget that term, and then it all comes out different, okay? Because if you multiply these two and forget that one, this one will actually have 0 solution, not infinitely many, okay? So, common mistakes over the years. This is what I see. And it's always like, oh, yeah, somebody else did that, okay? So, okay. For ones like this, I would like for you guys to rearrange the equations so that the x's and the y's line up in the same columns, right? So for example, this one, we're going to do y plus 4x equals 12. Yeah.
I know it says to do it by elimination, but like if we saw something that didn't say, would it be easier to do?
Yes, but if it tells you to do it in a certain way, yes, definitely. And then 3y plus 12x is equal to 8. Okay? Now, what can we multiply the first equation by? Negative 3. So now we get negative 3y minus 12x equal to negative 36. 3y plus 12x equal to 8. Add them. Left side, what do I get? 0. Right side? Negative what? 28, right? When is 0 equal to negative 28? Never. So this is no solution. So what does that mean about how they look? Parallel lines. So these are the same lines, and these are parallel lines. Okay? So those are pretty much all the possibilities. Now, like Tohar said, if you weren't just given these and you were told solve by any means, right? Solve by whatever method, this would, this one screams substitution, right? Whereas some of the other ones, like, you just kind of know. The beautiful thing about math, right, is, it's consistent. So everything will work for, all of them. So that's good, okay? All right. And wouldn't you know it? That's section 1. So now you can start the homework.